All right, we still have some folks coming, but I want to thank everyone for taking the time. I'm Steve Yolga. I'm the Director of Sales and Marketing with DoALL Sewing Products, and I'm going to give you just a couple of points here. One is, first of all, we know your time is valuable, so really do appreciate you spending a half an hour or so with us today. As most of you on the call may know, DoALL invented this technology and technique of cutting metal with a bandsaw blade back in the late 20s. And since then, we've been continuing to innovate and improve and expand our knowledge. We're fortunate today to have Tim Piehel, one of our most knowledgeable blade experts on staff, and he's going to be providing the information today in our webinar. If you have any questions during the call, during this webinar, please list those in the chat. And at the end of this call, Tim will stick around if you want to, and we can go through those one by one, or we will respond to each one of these and send the responses out to the attendee list. So once again, thank you for attending, and we'll hand it over to Tim.
Good afternoon, everybody. I just want to thank you for taking time out of your busy schedule and attending one of our DoALL Blade trainings. The purpose is to help understand blade technology to improve your efficiency in cutting. Our newest blade catalog, which you'll find on www.doallsawing.com, or ask your sales rep for a copy. There is a lot of helpful information in this catalog, and most of what we're going to discuss today is in this catalog. So I strongly suggest to get your hands on a copy. Let's just start with blade characteristics and geometries. I ask many operators when I'm out in the field, what does the actual cutting of a blade? And the most common answer out there is the teeth. That's somewhat correct, but the most important is the set. If you lose set during your cut's going to start going crooked. Whenever you put a brand new blade on a saw, it always cuts nice and square, but eventually it's going to wear and cut crooked. There's different reasons for why this happens. Most is deflection, and that can be caused when, say, for example, your saw guide arms are spread way too wide. You're going to get deflection. Could be a simple thing as band tension. You might never had your tension checked on your saw for a long period of time. It might be weak and you're getting deflection. Another reason could be that your saw guides are worn, so you're not holding blade at 0 point no more. And as you're doing cutting, you're wearing the side of the set on the tooth. So these are some of the things that can harm set. But when you look at the graph up there, you can kind of get, the different geometries and take a look and understand them. Do you know what your rake angle is on the blade you're using today? Most of you should. Basically, easiest way to explain rake angle. And I'm going to give you an example. Say we take a shovel and we come straight down with a shovel and we try to start digging some hard dirt. What do you have to do to be able to dig? You actually need to put more pressure to be able to dig. Now we take that shovel and we cock it a little, put a little rake angle on it. Now start digging. What actually do you need? You need less pressure to actually move that dirt. The more angle, the less pressure you need. You mainly need to know this because you've got to be able to set up your feed pressures on your saw comparing to knowing what rake angle is. when we start talking about set patterns, most of your set patterns are determined by the style of the blade. Most common out there is what we call a 4-set pattern or a 6-set pattern. And when we're looking at patterns, you know, the 6 set's going to cut faster than a 4-set. So you kind of should know what your pattern is. There's always one tooth at the beginning and the end of the pattern that's not set. This is known as the raker set. This does a dual purpose. It cleans out the kerf, and it also steers the blade through the cut. So let's take a look at some different examples. The one picture over in your left, that's a neutral rake angle, 0. Just think of that shovel coming straight down. If you look at the tooth point, you're going to see it's got a heavier tooth point. It can absorb shock. It's more of a blade for your 1018s, aluminum, those types. But then when we go to the next, we start getting the positive. This is where we're starting to cock that shovel a little bit. So your positives can run anywhere from 5 degrees up to 15 degrees, or actually 18 degrees. The more positive is when you want a higher positive when you start cutting tougher materials. Then to the right, you're going to see curved linear tooth design. This is a DoALL invention. And basically what we did, and you'll find this particular tooth on our penetrator blade, which in many years been very popular. But basically, when you look at it, we actually got a rake angle on it, but we have it that the tooth with that hook on there, you have a much stronger tooth. The other advantage of this blade is when that chip is forming in the gullet, it's acting like a pump and pumping the coolant. By forming it away from the backing of that gullet, coolant can get down to the tooth to give you much better blade life. So the next you're going to find, if you're using a vertical saw, this is a radius chart. It'll help you select the right blade you need to perform the radiuses. Again, this is in the catalog. In the catalog, we also have a chip chart. The newer blades are getting harder and harder to read chips because manufacturers are starting to play with rake angles and sets to increase chip removal. But you still want to be able to see a curly chip in solid materials. You won't see a curly chip in an interrupted cut. As you're cutting, just grab a whole handful of chips and sit them on the side and do comparisons through the cut or different materials. It's a good way to learn and understand chip control. Well, here's the old thing that everyone always questions is discussing blade break-in. It doesn't mean taking that blade and throwing it across the shop. That isn't what we're talking about here, and I'm sure nobody ever does that. Blade break-in is very, very important. I like using the number 2 lead pencil. So back in the old days, new days, everybody's using pens. We used to sharpen that pencil, and we had a real nice sharp tip. What we do, we went to right, we pushed too hard, and snap went the point. So what we do, we sharpen it again. We now went, and what did we do different this time? We wrote sulfur, less pressure. And we did that till we honed the point in. Same thing with the saw blade. You want to do identical. Here's our recommendation. So basically on a bimetal blade, so what we're saying is reduce the feed force for 20 minutes and cut at 50%. So what we're saying is, say, example, you want to be cutting at 10 square inches a minute. During band breaking, you run it at 5 square inches a minute for 10 minutes, and then gradually bring it back up and get to your 10 square inches a minute. But look at number 3, run normal band speed. When I'm out in the field and people tell me they break their blade, this is the #1 problem. You do not change your band speed during band break-in. Leave it alone right where it should be recommended. You take away band speed, you're just putting more pressure back on that tooth. Carbide, we do a little different. Carbide, we do turn down band speed by 30% or at 70% normal speed, cut our feed rate again at 10 to 5, but then you bring each one up gradually, a little bit different technique into breaking in a blade. This is important. You will get 30% more blade life if you start breaking your blades in. Here's the formula for cutting. If you guys don't know this formula, you should. I suggest writing it down. It's the most important thing in cutting. Many operators cut material, but have no clue if they're cutting efficient. A lot of them were trained over the time. When they get to the saw, the last guy said, well, you turn this knob, you turn that knob. But most guys, most operators are turning knobs and has no clue of what they're actually doing when they turn that knob. So you really got to understand your knob and know your formulas. If to start using these formulas, you're going to improve your cost of cut, which is crucial to the profit of the part. So basically, we're looking at cut time equals cut area divided by cut rate. So basically, we're looking for a time of how fast we should be cutting that part. So first thing, if you remember on the chart, it said basically we got to know how many square inches we're cutting. So let's look at this calculation, and we look at a square, okay? And this square is 5 by 5. If you divide this into little 1-inch blocks, you will basically find there's 25 square inches in that box. Pretty simple. We all know that one. But now, let's look at a circle. How do we do a circle? Well, you know, the old formula is pi r squared, but, you know, I'm no rocket scientist. So basically, I'm looking for an easy way. And when I hear pie, all I think about is cherry pie or apple pie. You know, I want really a simple way. So the easiest way to figure a square around is make it a square. Take it and figure, okay, it's 5-inch round. I'm going to be 5 times 5, just like in a square, 25. But there is 0.8%. There's 80% of a round in a square. So this particular has 20 squares in it. So start using your rounds and the easy way to calculate it. So next part on the chart, you need to know your cut rates. So basically, there's some different places you can get. Number one, you can again go to our website, pull up these charts, look at it. Or maybe some of you still have the old-fashioned slide rules. That's another way to get cut rates. Or we have an app. You can download it on your phone. DoAllSaws, and get the app and be able to come up with your cut rates there. This is also where you're going to pick up your band speeds for your different materials. So these are suggested starting rates to go to get you started. So when we're back looking at the formula, we know the cut area, we know the cut rate. What we're looking for is cut time. So gather this information, start using it. I can tell you, everything is formulas. When You know, the guy running the machining center, if he's running a lathe, they're working on formulas. The bandsawing is no different. You need to be working and taking and calculating your cut times to know whether you are making profit for your company. The next thing we're going to look at is, what pitch blade do I want to use? Again, you will find this chart in our catalog. And basically, if you look at this chart, take for example, if I'm looking at a 4-inch piece of material, which is up on top, I come down, you will see I can use either a 4-6 or a 3-4. Looks like 3-4 would be my better choice, but depending on what you have on the saw. So I'm going to take it one step farther, and I'm going to say, let's look at this 6-inch. So basically, I'm going to run over here to a 6-inch. And of course, my best selection is going to be a 2-3 pitch. Say you got a 3-4. What does that mean? You're probably going to have to use a little more feed pressure to penetrate the material or make adjustments to your feed pressures and rates. You'll find in our catalog also a section that gives you your blade pitch for I-beams, angles, and tubing. I'm telling you guys, this is a nice feature. I wish we would have done this years ago, but it makes life much easier. So basically, go in, you look at your shape, you'll see you got B's and S's. You'll go over to your chart and just say, example, I got a 6-inch I-beam. It got a 1/4 wall thickness. I want to use a 5/8 pitch. So this way, you're at least going to get a correct pitch for those angles and beams. Most like your slide rules and stuff, no one ever gave this information. So I find this very useful. Okay, let's look at teeth engagement. If you look at this picture right now, and you stand there, and if I count how many teeth is in the workpiece, and right now I can tell you, I counted for you, there's 23 teeth into the workpiece. The good rule of thumb to keep you out of trouble if you don't have a chart is to remember there's always 3 to 25 teeth you want into the workpiece at one time. If you got more or less, I'll show you a little later what's going to happen. So I have 23 teeth. I'm in the 3 to 25. I'm good. But now when I get down into the middle of this tube, you're going to see I have only 4 teeth into the workpiece. Okay? Still 3 to 25 teeth. I come down deeper, I have 25 teeth into the workpiece. Okay? Still into 3 to 25. I know I have the right blade for this application. Say I don't have enough teeth into it. Basically, when we're cutting, if I would take a scale and I put it under the tooth, I would measure, when we're cutting, we want somewhere 75 to 175 pounds of pressure. Okay? So if you take this picture I'm showing you, and I have 2 teeth, and I'm throwing 150 pounds of pressure on that tooth, I'm going to shock it. It's too much of a load. Most likely what's happening is I'm going to strip the blade. So now let's look at this picture. Here we got a little different scenario. When you look up on the top, I didn't count these for you, but you got probably the right amount of teeth on the top. You have the right amount of teeth on the bottom. It's falling between the 3 to 25. But what are you doing on the bottom? It's way more than the 3 to 25. This is a cut that you better start praying because there isn't really the right blade. Actually, you have the wrong saw to do this application. So what will happen is you get down there on the bottom, you get too many teeth into it, you can't penetrate it. So you would actually have to turn your feed pressure up a little when you get to that bottom area. but then you're going to overfill the gullets and just strip that blade out. I just want to bring this to everybody's attention. Chip brush plays an important role in blade life. Make sure it's working and is adjusted properly. If you don't, if that gullet is filled with a chip and it comes back into the cut, there's only one thing going to happen. If you ever heard a machine gun go off, you're about ready to hear it. So you want to make sure that brush is up into the gullets and to clean the chips. Don't carry chips back into the cut. Let's look at ordering a blade. You know, basically, our system that we have for blades is very simple. The first three numbers on the are the blade type. So that 333 is your blade style. The next set of three is the blade width and the number of teeth. And then the remaining three are the length of the blade in inches. So what you're going to find down there is basically is what we're doing is there's going all of our new numbers, our new part numbers, or new blades are set up this way. We still have a few of the old style that we have to get someday updated to this new blade characteristic numbering system. So let's look at the lineup of blades we actually have. Okay, so GP. You guys remember when I talked about the shovel? This is a 0 degree rake angle. So 0 degree, if you remember, the tooth is a lot thicker in a 0 degree rake angle. And you'll see that most of, when you're into the neutral rakes, you're going to see the pitch. They're normally a lot finer pitch blades. This kind of blade is good for your like 1018s, and it's good for your like aluminums or anything where you might have a little bit of an interrupted cut. Great blade for in that area. So then we go to our next blade, which is Silencer Plus. This is still an M42 tooth blade, but it's a positive. Remember the shovel, we're tilting it a little bit more to be able to make and get penetration. So basically, you will find this that you're going to use this on your thousands, like 1018s, your 1100s, your 1200 type steels. And you'll find it when you're cutting larger diameters. So it goes in and freely cuts for you. So that's the Silencer Plus. And that averages anywhere from 5 to 10 degree rake angle. The next blade is our structural blade. If you remember when I went back, we talked a little about set patterns. And I told you that there's a raker on there that does the steering and keep everything straight. Well, the structural has a unique set pattern. It's what we call 3-set pattern. It does have a positive rake angle, so it's a little bit positive. But because of the way we make this tooth, it's a very strong tooth. Basically, what also we do on this is on the top, we take and we actually grind the top part of the tooth. So that's like a protector. So when you go in and you start cutting, and if you break the tooth, the protector rides over and stops the next tooth from breaking or helps it prevent. So you don't have that machine gun that goes off when you break all, the teeth. So you can actually take this blade and cut with broken teeth throughout the blade, and it still will cut very straight and very square. Mostly this blade is an excellent blade if you got a tilt frame style saw, or if you got a horizontal mitering saw. You will find that this blade is a great selection that you should be looking at. Man, we just took this blade and we caught a structural prime. We gave it a boost. And what we did is we took our structural and we now put M81 material for a tooth compared to the M42. And if you actually, what's the advantage of an M81 over the M42 is when I'm cutting a structural beam, for example, my blade's coming in with coolant. I got nice coolant at the beginning of the cut. Then it drops off, and then it comes to the other side of the beam. And guess what? I don't have the coolant there no more. I'm creating heat. That's where the M81, having that powder metal tooth, will give you and save your blade life. So if you're using larger beams, this is an excellent blade. This is fairly brand new and something you should be looking at. Penetrator. Oh, this is our old standby. Remember we talked about the curvilinear tooth design? That's where we got penetrator. Great blade for cutting stainlesses, 4140s, those type of materials. It's, again, M42, and it has a rake angle of 15 degrees. So the other thing is we didn't talk, but this is a ground tooth blade versus a mill blade. The advantages of a ground tooth blade is the consistency. When we're manufacturing the blade, from the beginning of the run to the end of the run, it stays consistent. Where when if you have a mill cutter blade, as that mill cutter gets a little dull, your consistency drops off. So penetrator is our old standby. But guess what? We jumped it up a notch. We now took the penetrator and we have added the M81 material. So some of you guys might have tried the new M51 material and like that over the M42 material. I can tell you right now, look at this M81 because it will kick butt over the M51 material. I had a customer, he was asking about cutting D2 material, and he said, you know, and he's on the web asking us to talk about it. He says, do you cut D2 material wet or dry? Well, the answer is both. If you're going to pull a chip, and when I say pull a chip, I'm talking cutting like 6 square inches a minute in D2, you want to cut it wet and use the penetrator saw blade. But if you can't pull a chip and you're going to be under those 6 square and get the powder and you're going to be cutting dry, I would go to the Silencer GP, and because that way you won't be glazing and be able to cut. So pull a chip, wet, don't pull a chip, you have to cut dry. Hope that answers your question. Supreme. Supreme is our next notch up, and basically this is strictly an M81 material, but it is aggressive. It is 18 degrees rake angle. Think of that shovel. You don't need as much pressure to run this particular blade. I also want to make you aware that this blade in the 3/4 pitch and 4/6 pitch has a sine wave, which does a rocking or broaching action in the material. You use this blade in your Inconels, waspaloids, and those type of exotics. Now we look at our carbide line. And basically what you have is you got the T3, that's your standard 3 grind where we grind the left, we grind the right, and then the center one, we grind both sides. This is the old standby blade that just had for many, many years. But again, we took it up another notch. We now have the T7p Grind. And basically now that blade is basically, we're grinding 7 different patterns on the tooth. Every tooth is ground different. So you can run this blade faster. It's great in your alloys, your nickels, and those type. But don't try to read chips because it's next to impossible to do. For you guys that are cutting shafting, like hardened rods or cylinders where we're up in that 65 rod. We have what we call the negative rake blade. So if you're looking to cut any of that type of material, take a look at our T7p blade. We also make a line of set carbide. Set carbide is where we have a carbide tooth, but we actually bend it just like a conventional bimetal blade. This blade is mostly used in foundries in aluminum applications. We still make a line of carbon blades for your old-fashioned guys or your vertical saws. Basically, we have the dart and the metal master. The difference between them, the dart, the backing, you take it, you bend it, it comes back. The metal master, you bend it, it'll stay kink. Dart is a lot better blade over the metal master, but we still represent both of them. Friction blade. For guys who, basically never really saw friction, friction is at high speed. It's 15,000 feet that this blade is running. But we do have a line of friction blades. Take a look at them if you're doing this kind of cutting, like catalytic converters and stuff. Use friction. So you're cutting your gates and risers off. But we do have a whole line of friction blades. When we're getting into grid edge blades, we do have continuous, we have segmented. What's the difference between them? The segmented is your swarf. You have a lot of swarf. You need to have the gullet area to engage, to take the swarf and get it out of there. Use the segment. Other than that, use continuous. We have a line of diamond blades. We invented the diamond blade. We have a whole complete line. So if you're cutting quartz, glass, silicon, any of that, graphite, give us a call. We can help you in that area. The other thing we are now is we're into having circular blades. Now, these are not your blades for just chop saws. These are for cutting high speed type. When you're looking at these blades, you got to know, number one, the diameter. Number two, you got to know your arbor hole. Number three, you got to know your pinhole. And you got to know how many teeth per inch. These are the type of saws that will produce, say, for example, 2-inch round at 1018. It's going to cut that part in 10 to 15 seconds. So we're flying through the material, but if you're using any circular saws, give us a call. We'd love to work with you. If you want to talk about a circular saw, again, give us a call. We carry it from 200 to 285 millimeters. As you can see, the chart says 580. We actually now go to 880 millimeters. So keep us in mind if you get into this area. So basically, these are our national sales rep. And if you look, we have the area pretty well covered. You can see I cover down here in the southern central region. One thing I will say is if you take and look at our reps that we have and look at the years of experience, we probably have more experience on our staff than most saw companies. So this is on the website. So if you need to get a hold of us, there's our numbers. We all answer our phone morning to night. Guys, I kind of ran out of my time. I even went over a couple minutes, but I covered 2 hours of normal talk in less than 30 minutes. So again, as Steve said, basically, I will hang around for any questions.
All right. Thank you, Tim. And thank you to all that have joined us. If you have no questions and you need to get going, please drop off the call. We'll keep this line open for the next 15 to 20 minutes if someone has any questions. Stephen asked a circular saw for aluminum.
Okay. Circular saws for aluminum. We do not manufacture circular saws for aluminum. There's a couple companies that do. We do have saw blades available, but we do not, our machines, our current saws are not geared for aluminum, because when you're aluminum, you're running the blade much, much faster.
All right. Any other questions out there?
I had a question.
Yes, go ahead, Eric.
Can you hear me?
Yes.
Well, I deal less with the applications, more of selling. So, right. And, you know, after this, I know all applications, materials, and everything are different, right? But I seem to have a lot of guys that want to, you know, they think carbide's the answer, you know, and then after, you know, 5 full business days of my work and 3 weeks later, we circle back to, yeah, you needed a horizontal or chop saw, you know. So, I mean, is there, I guess what I'm trying to say is there, when does carbide come into play, I guess? You know, like you were saying earlier, you know, it's got to be what, you know, tougher material, kind of. I mean,
Okay, let me answer where carbide comes into play. The problem is, most of all, there's 2 things. To run carbide blades, number one, you got to make sure you have a saw that's capable of running carbide blades. So what I mean by that is, number one, you want like a saw that has a VFD drive system. You don't want something that has a VFD. You don't want variable pulley, but you want a rigid, heavy duty, because carbide cannot take shock. So any vibration or anything like that will just destroy a carbide blade, and you're wasting your money. That's why we have that M81 material. So the saw is very important when it comes to the blade, and unfortunately, most blade salesmen don't understand that. They're just trying to sell $1. Where really carbide will come into play is in your exotics. Okay, you definitely can get savings using carbide over bimetal. But as far as, go ahead.
Well, I was going to say, it's like, I don't know, there's 2 guys in particular in the last month that come to mind, right? And I think their agenda was basically, you know, they want to do it quicker and everything like that. And they thought carbide was the answer. And what I think really is the answer is those circular blades you were talking about just 5 minutes ago, right? You know, like that would be better, you know.
You have to be in high volume to be able to do that. So, you know, we're talking of a saw that's $100,000.
Oh, so, okay, like a high speed carbide type,
high production.
That's not on Scotch.
No, that's
all right. See, that's what I'm feeling. I'm like, I don't know enough to tell them, hey, I know.
Yeah. So, you know, on the chop saws, yeah, I mean, there is carbide, but that's a whole different type of a blade. The geometry and everything is different. But the biggest thing you have to understand in carbide, and this is where a lot of guys don't really understand, carbide is not to cut, it will cut a little faster. Okay? Carbide is there to give you more blade life. So your downtime is less. Okay? It only will cut like 10% faster than a bimetal blade. But it will last longer. So, you know, so that's where a lot of guys, I'll cut 50% faster. No, that's not a true statement. Unless you got one of these fancy elite saws. And that's a different story.
Then, I guess this is more of a theoretical question. So the guy who's looking at it, I've got what do you call it? I've got a big vertical, right? Unfortunately, it's not but I have a horizontal dual, right? And the guy's like, well, what one of these is going to cut faster? And I'm looking at the, you know, blade speed or feet per minute or whatnot, but you know, they're the same. And after talking to my dad, aren't they? So Does one cut faster than the other? Aren't they both forced by gravity almost?
On what?
Vertical versus horizontal. If someone is looking to do something
Okay,
like
if you're looking, then no. A horizontal will cut faster and give you better blade life than a vertical. Okay. And what it is basically on a horizontal, when you're coming down, you're using head weight. So you have a constant weight, which is giving me a constant tooth load. On a vertical saw, have to use some kind of a hydraulic or pressure to push, which is not constant. So I'm not getting the same equal tooth load through the cut. So that's why a horizontal versus a vertical, you will always get much better blade life because you got an even constant tooth load through the cut.
All right.
And you will also find a horizontal more rigid than a vertical. Because vertical is just sitting on some kind of ways or something.
All right, thanks, Eric. We got one more question, and if you think of another one, Eric, you can chime in. Tom or Tom E, I don't know which. What is the best blade to cut 16 gauge wall, 1 5/8 inch, stainless steel, hollow tube?
What width blade are we talking?
He's probably not going to be able to tell us because he's on mute. So why don't we give some options here, Tim?
Okay, so basically, if in that thin wall, you're basically going to go with the most finest blade you can get, and again, it's going to be determining the saw. So look at the GP and get to your 1014 or your 18 pitch blade. But use GP, and like I say, 1014 or 18, go on the catalog, look in those bracket areas, and get the finest tooth blade you can use. Band speed, I would run at 150 feet per minute. I think you said 304, correct?
You just said stainless.
Well, that we also need to know the type of stainless, because there's a big difference between 316 and 304.
Yeah, we'd be 304.
Okay,
Yeah,
there it is.
150 feet per minute I'd run it at.
Okay, thanks.
All right, Paul Myers asks, I cut a lot of hard chrome, 100 hardness in chrome, 2 inch to 3.5 inch. What would be the best blade?
Did I hear 100 Rockwell?
You said 100 hardness. Paul, if you can unmute yourself and you could tell us in your own words, 100 hardness in chrome.
And I would presume that's just a coating, not through the whole part. So the blade that I would recommend is that carbide that we talked about, that carbide neutral or negative rake angle blade.
So T3N.
T3N, you got to make sure you got a good saw. Don't try cutting it on like a 916. You got to make sure you got good flood coolant. You got to have some good head weight. I would be on a power saw, and if you're cutting that, and I would be running around 125 feet per minute.
Okay, Paul did say it's just coating.
Yeah. So
okay.
That T3N.
Any other questions, gentlemen and or ladies? All right. With that, if we have nothing else, we again thank you for taking the time. We had 31 of you stick around and ask questions. We appreciate it.
Jesse said hey.
Who did?
Jesse just said hey.
Okay, is this downloadable? You can contact us. We have recorded it. If you've attended this, we can provide you with the link to this.
I have one silly question. Maybe I know this is not an easy answer, but just back to the carbide versus the bimetal. Generalization or whatnot. When talking to someone, what is the cost? Right, the carbide is going to be a lot more, right? I mean, it's
Three times the price of bimetal.
awesome. Thank you.
All right, folks.
Thank you guys very much.
No, thank you all. We're gonna conclude the session. Again, contact us if you have any further questions. We're more than willing to talk to you. We live and breathe sawing. So thanks again, folks, and have a super rest of your day. Bye bye now.
Thank you, everybody.